Hello everyone, welcome to my math class. In this video, I'll show you how to read a dial indicator or a dial gauge. With a dial gauge, you can measure runout. Runout means you can check rotating parts for straightness, such as an axle. You can check your brake rotors for straightness or your wheel. You can check for straightness the chuck on your drill or drill press, or you can measure runout on your lathe. It's important that these parts be rotating straight. Measurements will be covered on another video. On this one, what I'm covering is how to read this dial gauge. So, other than this one is mounted on a stand and has a magnetic base, its functional part is its dials. It's got two dials on it with two needles. The outer dial rotates and the other one is fixed. I'll make sense of the numbers and I will get you a close-up in a sec. The other functional part is this probe here that has a 1-inch throw. I know this is a 1-inch throw because I can just very simply measure it like so. It's a little more than 1 inch, but that little bit is not important. I'll explain in a sec. As this probe pushes in, you can also see that it's extending at the top and there. And this key to reading a dial indicator and to make sense out of those numbers is that this 1 inch of straight line travel corresponds to an exact amount of rotation on the dial. Inside the gauge there's a bunch of gears. Well, to be exact, there is a rack and pinion mechanism inside. So there's a bunch of gears and the ratio is set and is constant for those gears. So a certain amount of straight line motion will consistently always cause the same amount of rotation on the needles. So that's key to understanding this. Another thing, and this is where your model may be different, but you can make sense of the numbers themselves, that if you just measure this 1 inch, you need to know what the gearing ratio inside is. You need to know how many full turns does the main needle take that corresponds to this 1 inch of straight travel. To do that, just set it to 0, like so, and count the number of full turns. The partial turn, don't worry about it. That there's going to be a partial turn, but that partial turn is just there so you can set your 0 without hitting a stop in the gearing mechanism. So let's count the number of full turns. There's 1 full turn there, 2 full turns, 3, 4, 5, 6 full turns, 7, 8, 9 full turns, and 10 full turns. And other than that, there's an extra half a turn, but that is really for setup, and there's also a little bit of play inside the gears. So 1 inch means 10 full turns on the dial. So that means that 1 turn on the dial corresponds to 1/10 of an inch of straight line motion. Okay? Because it takes 10 full turns to cover the inch. Therefore 1 full turn, like so, that's 1/10 of an inch. Okay, that's important. I'm going to write this one down here. So 1 full turn equals, I'm going to write fraction as well as decimal, 1/10 of an inch. That's those two whiskers, that's how you write inches, and 0.1. So 1 full turn is 1/10 of an inch. Now, another thing is, take a look at the numbers. Let's start there. The big numbers on the outside dial read 0, and then 10 and 90, 20 with 80, 30 with 70, 40 with 60, 50, 50, and you can see the rest of the numbers. Now the numbers on the smaller dial here that doesn't move, it reads 0 and then it says 0.5. Yes, there is a point in front of that 5. And then it reads 0.1, 0.6, 0.2, 0.7, 0.3, 0.8, 0.9, 0.4, and we're back to 0 with 0.5. I read it counterclockwise because the smaller needle rotates counterclockwise like that. Okay, so let me explain the meaning of those small numbers on the smaller dial. So let me set it to 0 there. Like I said, it takes 10 turns to travel 1 inch. So I'm gonna make one full rotation on the main needle, on the big needle. There, it took one full rotation, and you can see that the little needle is pointing at 0.1. That means that on the probe 0.1 inch of travel has been taken. 0.2 inches is the advance, 0.3, no, sorry guys, it doesn't have a quarter inch or something, but quarter inch would be somewhere there, the 0.25, 0.3, 0.4 inches is there. After 5 full turns on the main needle, the smaller needle is pointing again at 0 and 0.5, and then you read the little dial as 0.6, 0.7. Now, the only way you can tell whether it's 0.2 or 0.7 is you look at the probe here and take a visual look how much has it traveled. 0.2 would be here and 0.7 is somewhere here. That's really the only way to know. And if you start actually at 0, 0, like there, when both needles are pointing at 0, you're gonna have to count the full turns and go 1, 2, 3 full turns, 4, 5 full turns, and then 6, 7. So you're gonna have to keep it in mind where you were at the beginning, and after 7 turns you have traveled 0.7 inches forward. Okay, that's how to make sense of the little dial, or the numbers on the little dial and the little needle. Now the big one is somewhat simpler, and at this point I'm going to tell you it's extremely finicky. So if I put my clipboard or pen or something on the table, it's gonna make the needle move. See, okay, or here is my clipboard. If I just lift it up or whatever, it's making the needle move. So please work with me on this one. I'm going to try my best to set it to 0, but just be patient there. Okay, the main needle, the big needle, is at 0. Now, like I said, one full turn is 1/10 of an inch. You can still see it in the background there. If you count the number of hairlines on the main dial, on the big outside dial here, you can see 1, 2, 3, 4. The fifth one is a little longer. 6, 7, 8, 9, 10, 11, 12, 15, 20 of these lines, 30, going around 40, 50, 70, 80. 80 is here, 90 of these lines, 95, 99, and what comes after 99? 100. The outer dial has 100 parts. So that means that the one full turn, the 1 inch, has been divided into 100 finer parts. The question is, what amount is 1/100th of a 10th? One full turn is the 10th, and we have 100 nicely evenly spaced lines to cover that 1/10. So I'm just gonna pull this one a little bit aside here and set it back to 0 again, or so. Getting there. So to make it fast, each hairline on the outer dial is 1/1000th of an inch. So I'm going to just write 1/1000 inches in fractional format there. And I'm gonna do it with my clipboard in the air, okay? So I can set it back to 0. Or in decimal format, it's 0.001. There, if I don't hit anything, 0.001. And that number you can see printed by the manufacturer thereabouts on the dial indicator to tell you that the smallest increment is 1/1000th of an inch, and then it reads 0.01 inch dash 1.0 inch, meaning that after 10 full turns you will be reading a 1 inch of travel. Okay, so every increment is 1/1000th of an inch. Consequently, if I set it to say that number, we have traveled 4/1000th of an inch forward. Please note that the gearing is also moving the little needle counterclockwise. So 4/1000th. The next number is, say, 6/1000th there. And how these look like in fractional format is, this one is 6/1000, or in decimal format 0.006. I'll try not to hit anything. There, so far so good. Now we're gonna get to the number 10. There, 10. You can write very simply in fractional format 10,000th. So far we traveled 10,000th of an inch. Or you can simplify it by crossing out 2 zeros, simplify this fraction like so, and you can read it as 1/100th of an inch. 10/100th or 10,000th or 1/100th of an inch is the same thing. And in decimal format this looks like there. There is 10,000th of an inch, or I can cross out the last zero and just go 0.01, 1/100th of an inch. Now, next sheet of paper, and let's keep going other way. So that number would be there we go. That number would be kind of close to, almost there at 17,000th of an inch, and you cannot simplify that fraction at just 17,000th of an inch. Okay, that one is 21,000th of an inch. Let's go up to 30 there, thereabouts, 30. And how you write that number is, again, 30/1000 to make it look like, oops, I kicked it, 30/1000. There, we're back in action, 30/1000. Or again, you can cross that 2 zeros and go 3/100th of an inch. Or in decimal format, just go 0.03. That's how it looks like, 0.03 or 3/100th of an inch. Now as we go around, I'm gonna make it just go around this way. You can please notice that the little needle is also moving forward as they are geared together with the big needle. So that would be 7/100th of an inch, 8/100th of an inch, 9/100th of an inch. That one is 98,000th of an inch, and if we get back to 0, 98,000th of an inch, and that one is 100,000th of an inch. 100/1000 in fractional format, like so, 100/1000. Now from this fraction you can cross out 2 zeros, and well, 2 from the numerator and 2 from the denominator, and then we're back to 1/10, or 0.1 1/10th of an inch in a decimal format, like so. Now we're not done, because what happens if you have that measurement there? Now this one is 4/1000th of an inch if the little indicator down at the bottom is pointing close to the 0, but it isn't. It's pointing close to the 0.1, 0.6. I know we only traveled one turn, so it's gonna be 0.1. So now we need to add 1/10, where is it? 1/10 of an inch plus, let me just set it back to 4. Just give me, there, we're back to 4. So we have to add 1/10 plus 4/1000, there. In fractional format, 1/10 plus 4/1000. That's why I used the fractional format with all of its zeros. Please remember that 1/10 is the same as a 100/1000, and 100,000th plus 4,000th is easy to add, because 100,000 plus 4,000 is 104,000th of an inch. That's what you're looking at. And in a decimal format, it is written like so: 0.104. This is 104,000th of an inch. That's what you're looking at. Let's take another one. Let's go forward. How about that one? This one is 110,000th of an inch, which looks like, I'm gonna new sheet, 110/1000 in fractional format looks like that. Yeah, I know it's out of focus, but I don't want to hit anything on the table. And if I cross out the last two zeros, it's the same as 11/100th of an inch. So my policy, or what I do with this dial gauge, I read everything in 1,000th, and if I can, I simplify the fraction, but not really, because it's more meaningful or easier to take a reading in just 1,000 format. Here, 110/1000 is the same as 11/100, and 11/100 in the decimal format looks like that, 0.11. Okay, last two measurements, because it's been taking a long time. There, it's pointing at 25. That means that so far we've traveled one full turn, that's 100,000th, plus 25, so that's 125,000th. You can just read it like that. I'm going to spin it ahead, so we traveled 2 full turns. How about 3 full turns? Sorry guys. How about if I set it there, just a little bit back, like so. I'm gonna reset the camera, because there, that's a better angle. So on the little dial there, you're gonna start with that one. From the 0 it went to the 0.1, 0.2, 0.3, and it's showing you that it's a little past the 0.3, the 3/10 of an inch. Let me just pull it sideways so I can smuggle in my clipboard there to your right side of your view. So my first number will be 0.3, and I'm gonna write that one down, 0.3 there, or 300,000th there, 300/1000, because 3 full turns are 300 parts. Okay, and every part is 1,000th. So to get back to where were we? Okay, let's it's so touchy. Okay, let's go with that number. Okay, so far it's 0.3, that's a given, 3 full turns, and then it's pointing at 13. So what I need to do is add 13,000th, add 13,000th to the 300,000th. 300 plus 13 is 313/1000. So I'm gonna write 313,000th of an inch, just like so. Or in decimal format, I'm gonna just write 313 there. So 0.313, that's what you're kind of looking at there in the upper part of the picture. Okay, that's how you work it out with the fractions and the decimals. Again, you're gonna have to take a look at the needle indicating the full turns, as well as combining it with the amount of turn taken by the main needle there, and it's very finicky. So when you take measurements on axles or check your brake rotors or wheel for run out, it's gonna be finicky and nerve-wracking, and it's gonna need a lot of patience. Okay, in my next video I'll show you how to check an axle for run out. Thanks for watching.